Hello student, in this lecture we will discuss about signal flow graph. This is our lecture outline where first I will discuss the definition of signal flow graph. Then we will discuss about terminologies of signal flow graph, and after that we will solve some examples based on signal flow graph. Next, we will discuss about Mason's gain formula. Basically, this Mason's gain formula we will use to find out the transfer function of signal flow graph. After that, we will see how signal flow graph can will be obtained by block diagram of a system. After means we will see how a signal flow graph will be obtained from a block diagram of a system, and after that we will solve some example where we will obtain signal flow graph from block diagram, and after that we will find the transfer function of that system. So let's begin our discussion. So basically, block diagram gives a pictorial representation of a control system by way of shorthanding the transfer function. Signal flow graph further shortens the representation of a control system by way of eliminating summing symbol, takeoff point and block. So these elements means summing symbol, takeoff point and blocks all are the elements of block diagram technique. Okay, so this elimination is achieved by representing the variables by points called nodes, and the transfer function is termed as transmittance, which is represented by a line called branch. A signal on the branch travels in the direction of an arrow indicated on the branch. So basically, block diagram is a pictorial representation of a control system, whereas signal flow graph is a graphical representation of that control system. Okay. To find out the transfer function of signal flow graph, we have used Mason's gain formula. Okay. So this formula was developed by Samuel Jefferson Mason. Okay. According to his name, this formula is called Mason's gain formula. So what are the advantage of signal flow graph over block diagram reduction? So advantages is for complicated system, when block diagram reduction method becomes tedious and time consuming, then signal flow graph is a good choice. Okay. A signal flow graph consists of a network in which nodes are connected by direct branches. Okay, let's see. This is our block diagram reduction. This is our block diagram representation. Okay, and this is our signal flow representation for same system. Okay, here RS is our input signal and CS is our output signal. See, in signal flow graph, this RS and CS is represented by this dot. Okay, this dot. So this RS is represented by this dot and CS is represented by this dot, and this dot is called node. Okay, and this two node is connected by this arrow, and this is called branch. Clear? So this is our block diagram reduction and this is our signal flow representation. This is our block diagram. This is signal flow representation. In signal flow, we have seen the two nodes means input or output represented by nodes, and these two nodes are connected by a arrow, and this arrow is called branch. So here see, a signal flow graph consists of a network in which nodes are connected by direct branches. Okay, clear how they are connected? We have seen right now. The input node and output node are connected by an arrow, and this arrow is called branch. So these two nodes are connected by direct branches. Okay, it depicts the flow of signals from one point of a system to another and gives the relationship among the signals. Okay, now we have already seen there are so many elements in block diagram. One is summing point, second one is take-off point, and third one is block. Like block diagram reduction, there in signal flow graph there have some elements. So elements are branches and nodes. Okay, branches means system, okay, and nodes means signal. Okay, then see in this slide where nodes means signal. So here RS is input signal, CS is output signal, so they are represented by nodes, and branches are system. So this GS is represent a branch, represent a system. So this GS here indicate by this branch. Okay, so branch represent the system. Now if we take a simple equation like y equal to ax, then how we will represent this equation by signal flow graph? Let's see. So this equation is represented by signal flow graph in this manner. Okay, so here the variable x, when multiplied by the term a, results in a new variable y, or we get the equation y equal to ax. Okay, so from this signal flow graph we have said every variable in a signal flow graph is represented by a node. Here two variable, one is x and one is y. This is input variable, this is output variable. So every variable in a signal flow graph is represented by a node, and every transmission function in a signal flow graph is represented by a branch. Transmission function means here A is transmitted, so this is represented by a branch, and branch are always unidirectional, means they have only one direction. Okay, and this direction is indicated by arrow. So here say the arrow in the branch denotes the direction of signal flow. Okay, now here we will discuss the terminologies of signal flow graph. So first is node. So node is a point representing a variable or signal. So generally a node can be represented by this dot. Okay, here this is dot x, this dot. Node can be represented by dot. So this node representing a variable or signal. So if you want to represent any signal, then you represent that with node only. Let's see the equation. here x2 equal to t12 into x1 plus t32 into x3. Okay, so x2 is a combination of these two element. So if we represent this equation by signal flow graph, this like in this manner, we represent this equation by signal flow graph in this way. So here this is x2 and x2 is a combination of the t12 x1 plus t32 x3. Okay, so this is our x1 node and this is our x3 node. So and this is the transmittance. Okay, so and t12 is transmittance, t32 is transmittance. So how we will get x2? X2 is a combination of x1 plus t12. So see x1 when multiply t12 and come x2. x1 is multiplied by t12 and come x2. In the same way, x3 multiplied by t32 and come to x2. And then join. So we will get x2. Okay, so x2 equal to t12 plus x1, t12 into x1 plus t32 into x3. So here from this signal flow graph, we have seen there are three nodes or three variable. One is x1, another one is x2, and third one is x3. There are three variable x1, x2, x3. Or this variable represent by node. Node means this dot, x1, x2, x3. So node represent a system variable which is equal to sum of all incoming signals at node. Okay, now come to another point, branch. What is branch? What is branch? A signal travels along a branch from one node to another in the direction indicated by branch arrow, and in the process gets multiplied by the gain or transmittance of the branch. Okay, so this is if x1 and x2 are two nodes, so these two nodes are connected by this branch. If we put a gain or transmittance here like G, so x2 equal to G into x1. Basically branch is where branch indicates where two nodes are connected. Basically branch is the line joining of two nodes. Okay, clear? So what is branch? Branch is line joining of two nodes. Here x1, x2 are two nodes and these two nodes are connected by branch, connected by line, and this line represents the branch, or this line called is branch. Okay, and now come to input node. Input node, what is input node? Node which has only outgoing branch. So here see the diagram, this diagram. So what is input node? X1 is only input node because it has only outgoing branch x1. Okay, so next, output node. Output node have only incoming branch. Okay, so if you see this diagram, then what is our output node? X2 is our output node. So because x2 have only incoming branch. Okay, so next of the part I will discuss in the next lecture. Okay, so today I will stop here. Thank you.